When the SRS control module detects a collision event worthy of pretensioner deployment, current from storage capacitors within the module discharge through the high and low side drivers to the pretensioner circuit and squib. This current detonates the squib charge, beginning the chemical reaction within the gas generator. The expanding gas is used to move a plunger within a fixed length cylinder. Pyrotechnic type seatbelt pretensioners can be the stalk or attractor mounted, but their diagnosis can be treated the same. Pretensioner squib circuits have a fixed internal resistance. Faults will occur if this resistance goes above or below a predetermined limit. The most common failure for SRS pretensioners is excess circuit resistance. Navigate to the pretensioner data on the scan tool and compare the circuit causing the DTC with the opposite side pretensioner. If the value is excessively high, the first thing we need to do is perform a wiggle test on each connector in that circuit. Watch the data display while performing this check. If the resistance drops to specified levels, the resistance will be in that connector. Remember to disconnect the battery or remove the SRS fuse to allow the module capacitors to discharge. Do this before removing any SRS connector. If the fault remained present during the wiggle check, intrusive testing will need to be performed. The only way to test these circuits accurately is with a scan tool and a dummy load. With the ignition off, disconnect the battery or remove the SRS fuse and wait for the module capacitors to discharge. This may take up to 20 minutes depending on the manufacturer. Disconnect the pretensioner relating to the fault code and install the dummy load. Each manufacturer will have their own special tool for this purpose, but once you've sourced the specified resistance value, an aftermarket tool can be used safely. Reconnect the battery or install the SRS fuse and navigate to the pretensioner data using the scan tool. If the circuit is now within specifications, the excess resistance must be in the pretensioner squib. If the resistance value is still not to specifications, move the dummy load to the next connector in line, while observing all fuse removal or battery disconnection procedures as earlier. With the ignition on, recheck the resistance value with the scan tool. If the value is now to specification, the excess resistance is within the section of harness just disconnected. If the value is still excessive, perform the battery disconnection procedure again. Check for terminal tension and corrosion at the SRS module. If this check was deemed to be okay, then the excess resistance must be in the control module itself. A DTC that presents as an open circuit fault can be treated the same as an excess resistance failure. Follow the same procedure we have just performed. Never use an ohm meter to check the circuit resistance of any pyrotechnic device. However unlikely, the small current from the meter may be enough to trigger the squib. With the restraint system disabled, pretensioner disconnected and the shorting bars removed, turn the ignition on. Using a multimeter set on volts, connect the black lead to a known ground and check each circuit at the pretensioner connector for any voltage reading. The meter should display 0 volts. Any reading at all would indicate a short to voltage in that circuit. Disconnect the module connector and observe the meter. If it still displays voltage, then the short is in the harness between the two connectors. If the display dropped to 0, then the short is in the control module or a circuit from the control module. Perform a continuity test between the affected circuit and all other terminals in the module connector. If there is any continuity, the short is between those two circuits. However, if continuity was not seen, then the short must be in the control module itself. If the DTC indicated a short to ground, connect the red meter lead to a known voltage supply. In this case, terminal 16 of the DLC is a handy location. Again, with the restraint system disabled and the pretensioner disconnected, shorting bars removed and the ignition back on, test each circuit of the pretensioner harness with the black meter lead while observing the display. Any reading at all will indicate a short to ground in that circuit. Disable the restraint system and disconnect the control module. Turn the ignition on and repeat the test. If the meter displays any voltage, the short is in the harness between the two connectors. If no voltage was seen, the short to ground will be in the control module or a circuit from the control module. Perform a continuity test between the affected circuit and all other circuits in the module connector to isolate the fault. If no continuity is seen, then the short must be in the module itself. It's a good idea when testing for circuit shorts to wiggle the harness while watching the meter display. This may reveal an intermittent failure. A common failure for pretensioners is the high and low control circuits may short together. This may be caused by incorrect harness location or external interference. This check must be performed with the ignition off and the system disabled. With the affected pretensioner disconnected and the shorting bars removed, perform a continuity test across the harness connector circuits. Any reading seen will indicate a short between both circuits. Disconnect the control module while watching the display. If the meter value changes to open, then the short is within the module itself. If continuity remains, the short is between the two connectors. It may be necessary to flex the harness to localise the short circuit. It doesn't matter the make of vehicle or the location of the tensioner. If you take your time and are methodical with these checks, diagnosis will come easy. Thanks for watching.